So what does it mean when we say sine squared x plus cosine squared x equals 1? What does this mean? This means if we plug in any number into the variable x, we will get 1 as the sum of those two functions as they get evaluated. So sine, cosine, and tangent, they are nothing more but ratios of the sides of a right triangle. You know it's a right triangle when you see that little square on the side, which represents a 90-degree angle. So the ratios can be best described by the acronyms SO, CATOA. SOHCAHTOA. The first letter tells us what function it is, sine, cosine, tangent. Now the O stands for opposite. Because the ratios, they're being divided by each other. The next one's going to be the hypotenuse, H for hypotenuse. C, cosine, and then the A stands for adjacent over hypotenuse. T stands for tangent, the O stands for opposite over adjacent. Okay, I shortened it up a little bit because I wrote it already right there. So let's say we have theta, right? Sometimes it's going to say theta, x, it doesn't matter what it represents because the sine of this angle is the opposite over the hypotenuse. Let's say we have side length 3, side length 4, and 5 for the hypotenuse. We know it's the hypotenuse because it is directly across from the largest angle, 90-degree angle. Okay, so sine of this angle is going to be the opposite over the hypotenuse. So in this case, sine of theta is 4 over 5. Cosine of theta is the adjacent over the hypotenuse. So the adjacent right next to it, not the hypotenuse, but the adjacent over the hypotenuse. Okay, so you're probably wondering, Andy, 4/5 plus 3/5 is not 1. That's because it's sine squared of x and cosine squared of x. So that's what we're going to do. We're going to square both values right here. When you have 4/5 squared, that is 4 over 5 times 4 over 5. You just multiply straight across, which gives us 16 over 25, plus 3/5 squared is 3 over 5 times 3 over 5, which is 9 over 25. You can get a calculator if you want, but that gives us 25 over 25, which evaluates to 1. If you have any questions, I'll be here all day.